Hi everyone, today we are going to learn 5.2, which is use perpendicular bisectors. A perpendicular bisector, it's a segment, ray, line, or plane that is perpendicular to the segment at its midpoint. So remember, midpoint means point in the middle. So perpendicular creates a 90 degree, bisect means cut in half. So CP cuts segment AB in half, so AP is congruent to PB, and it also makes a 90 degree angle. Perpendicular bisector. Points on the perpendicular bisector of a segment are equidistant from the segment's endpoint. Equidistance means the same distance. So what that is saying is that X is equidistant from points A and B. So we then know that this segment is congruent to this segment. So use the perpendicular bisector theorem. BD is a perpendicular bisector of AC. We want to find AD. So that means that this segment is congruent to this segment and we create a 90 degree angle. Well, from the previous slide, if BD is a perpendicular bisector, D is equidistant from point C and point A, which means these two segments are then congruent. All right, so let's do some math here. So 3x plus 14 is going to equal 5x. All right, so if I subtract 3x from each side, I get 14 is equal to 2x, which means 7 is equal to x. And I'm done. In the diagram, WX is a perpendicular bisector of YZ. A, what segment lengths in the diagram are equal? All right, so here's my diagram. Let's talk about what we know. So WX is a perpendicular bisector of YZ. So being a perpendicular bisector means that it cuts XY in half. So this segment is congruent to this segment at a 90 degree angle. All right, which means W is going to be equidistant from point Y and point Z. So I can make some tick marks here. So right away, I know all of those tick marks are congruent. So I guess I could write this out. X, Y is equal to XZ, and WY is equal to WZ. Also, looking at this diagram, I see that YV is 25 and ZV is 25. So that means at this point that this segment is congruent to this segment. So let's write that. We have VY is equal to VZ, which we know is equal to 25. Part B said, is V on segment, or I should say line, X or WX? So can I extend this line and would it go through point V? Well, the correct answer is yes, it would. Why do I know that? Well, since VY is the same length as VX, and we know by the perpendicular bisector theorem that a point on the perpendicular bisector is equidistant from the endpoints, V would have to be on the line. So I'll kind of write that out. So since VY is equal to VZ, V is equidistant from Y and Z, which means V is on the perpendicular Let's say perp bisector. Bisector. All right, we want to find the length of AB. So there's a few things we need to do here first. Looking at our picture, we have a perpendicular bisector. BD is a perpendicular bisector. Doesn't tell me that, but if I look at my diagram, I see that this segment is congruent to this segment, and it creates a 90-degree angle. That's the definition of a perpendicular bisector. So if I have a perpendicular bisector, I then know that this segment is congruent to this segment. So let's do some math here. 2x is equal to 5x minus 6. I'm going to add 6 over to the other side. So I have 6 plus 2x is equal to 5x. Let's subtract 2x over. So 6 is equal to 3x. And that means that 2 is equal to x. But 2 is not my answer. I wanted to know what is the length of AB. So I need to plug x back into my equation for AB. So 2 times 2, which is equal to 4. So AB then is equal to 4. Let's tell whether the information in the diagram allows us to conclude if C is on the perpendicular bisector of AB. All right, so here is C. If we, drew a perpendicular bisector, I'm just going to draw a very bad picture. Would C be on that perpendicular bisector? Yes or no? Well, it would be yes. Since we know that these two segments are congruent, we know C is equidistant from A to B, meaning it would be on the perpendicular bisector. So this would be yes. How about number 5? Would C be on the perpendicular bisector? All right, so if I look here, I do see that these two segments are congruent. But do I know that C is equidistant from B and A? I don't. So there's not enough information here. So the answer is no. All right, for number 6, if I look at this, is C on the perpendicular bisector? Well, let's look at our picture. So here would be my perpendicular bisector. I see that these segments are congruent. I see a 90-degree angle. What I'm also told is that these two segments are congruent. So this point here is equidistant from A and B, which means since this point, I'll call it point D, since point D is on the same line as point C would also be on the line of the perpendicular bisector. So the answer here is yes. Concurrent. Concurrent is when 3 or more lines, rays, or segments intersect at one point. And that point that all the lines cross is called the point of concurrency. So I drew the point of concurrency in our first example. Point B here would be the point of concurrency in our second example. The perpendicular bisector of a triangle intersect at the point that is equidistant from the vertices of the triangle. So if PD, PE, and PF are perpendicular bisectors, that means that PA, PB, and PC would all be congruent. They would be the same length, and I'm going to draw that out here. So AP, BP, and CP are all the same length. And that point of concurrency is called the circumcenter. And this vocab word you'll want to know, you'll want to write it down. Sometimes the circumcenter isn't inside the triangle. This would be as in an obtuse triangle. So if we find the perpendicular bisectors of each side of the triangle, find where they cross, in obtuse triangles, they're going to be outside of the triangle. For a right triangle, the circumcenter is going to be on the hypotenuse, actually on the triangle. And I'll go back a few slides. Acute triangles are when they are inside the triangle, like in this example here. So acute, it would be inside. Obtuse, outside. And for right triangles, it's going to be on the triangle, on the hypotenuse. And this slide is just kind of repeating what I just told you. So the circumcenter is the point of concurrency of the three perpendicular bisectors of a triangle. You need to know that, write that down. So the circumcenter P is equidistant from the three vertices. So P is the center of the circle that passes through all three vertices. So for acute triangles, P is inside. For right triangles, P is on the triangle, and for obtuse triangles, they are outside. I would maybe draw this in your notes or at least write this down. That way you have that for the future. And finally, in the diagram, the perpendicular bisector of triangle ABC meet at point G. So that means G is the circumcenter and are shown dashed. Find the indicated measure. All right, so first we want to find AG. So I'm going to highlight AG. So AG, we know from our theorems that AG, GB, and GC are all congruent. So what is the length of AG? Well, it would have to be 25 because we see that GC here is 25, which means this is 25 and this is 25. All right, let's go to 14. Find the length of BD. All right, well, BD would be here. If I look at the diagram, I know what AD is. AD is 20, and because point D is the midpoint, that means it's in the middle. So DB would also have to be 20. Let's look at CF. All right, well, once again, we know that point F is a midpoint because we have perpendicular bisectors. So if F is in the middle, we know that CF must also be 24 since AF is 24. BG, BG, I'm going to highlight this with the red now. So BG is right here, which we already have highlighted, knowing that it's 25. CE, all right, so CE is right here. So if E is in the middle, what is the length of CE? It would have to be 15. And finally, AC. So AC is this entire segment right here. So if half of it is 24, the other half is 24. If I add these up, what do I get? 48. So 48 is the entire length of AC. And I'm done.